This talk is a little bit weird, and it's actually my first weird talk because usually we do nerdy stuff with math, and I tried to do some kind of experiment regarding the social aspects of creativity and artificial intelligence, because everybody's talking about artificial intelligence these days. And of course, everybody knows, I guess, in this conference that doesn't mean much because we need to know what intelligence is. And we surely know it's not classifying dogs or cats. And there is a definition of intelligence that I like particularly, which is the idea of taking two concepts and creating a third one without impairing the two first. And so basically this definition by Chomsky is very important, but in any case, the problem we have with this approach to creativity is that anything that is labeled as intelligent is creating these passionate and kind of unhinged debates. So if you type will AI, it will always be take my job, replace radiologist, which is weird to be the second research in Google. I don't know why. And it's even worse if we start to ask the question related to creativity, because on one hand, we have something which is very central to our humanity, but which is quite poorly understood. And on the opposite hand, we have something which is very mathematical logical and try to solve formal problems with well-defined goals. So the meeting point is something that I guess in many cases we've seen approach trying to do these self-contained ex nihilo generative machines, which, you know, you have a big button where it generates stuff and it tries to purely mimic human creative traits. So a bit of a warning there is that I'm not a sociologist, but I'm taking inspiration from sociology and I'm trying to do the opposite of what has been done, something I call mathematical reification of ideas. So trying to take something biological and project it on a computer science or mathematical domain. Here I'm trying to do the opposite. What if AI was to pass a creativity test as is defined by the sociology field? So when we talk about creativity, most of us will always think, oh, it has to be something novel, right? Creativity means innovative things. And of course, it should be also of some quality, so it has some appeal. But this only pertains to the content of the idea. And the problem is that actually creativity is also very much about the context where the idea is defined, because creativity is a contextually embedded phenomenon. So significance cannot be only on the content, but also within the social framework and historical period where things came along. So I don't know if you've seen, there is a great video of the first introduction of the Moog synthesizer. So it's in an opera house, and you know, when the synthesizer plays, people start to either frown or some kids cry actually when they hear their first synthesizer sound. So I removed the video just now because it's 5 minutes and I surely don't have the time, but I can send you the link afterwards. So I'm taking another big argument that I find very interesting is that, you know, when you model something, there is usually a norm. And of course, this applies to anything, not only music, but also science, art, people. So the idea is that the majority of ideas kind of gravitate around the norm of this idea. Depending on how much these ideas follow the norm, they are more or less close to the center. And of course, there is not one norm because it would be boring. There is rather a constellation of local norms of ideas, and these kind of gravitate around each other. So now, when something new appears, it looks at the beginning that is kind of too eccentric, you know, too far from any norm. But some ideas start to form around this eccentric group. So when people share common norms, distinct from the majority, it looks less weird and outside, and it can move around the space of ideas. And if some idea gains some momentum, they can even attract other ideas towards them. So this could go up to shifting the norm of previous ideas. And even though some people might be reluctant to the change, this can even create a new norm. And then after a while, when many ideas have been gravitating around both norms, it creates different norm where the previous one remains. So sometimes when we try to model things with machine learning or trying to talk about creativity, we are looking to model this kind of next thing. So the question is, how could we do it? And why is it so hard with machine learning? So the big question here is, how do we evaluate them? So how first could we create two axes which are orthogonal to each other, one from intelligence and the other for creativity? The larger question is, how do we evaluate creativity? So it's a very controversial topic of psychometric studies, which also pertains to the question of measure theory, like is everything measurable? Because when you measure something, and mostly with subjective questions, you need to have something which is reliable, which means that there is some consistency in your evaluation. It needs validity, which means you need accuracy of the measurements, and discriminant validity, which is very hard for creativity because it's hard to separate creativity and intelligence somehow. So what kind of tests or measure of the creativity of AI could we use? So if we look in the sociology field, there is this person named Ellis Paul Torrens, which is considered as the father of creativity. And it did this test called Torrens tests of creative thinking, which is actually still one of the mostly used tests, which is asking unusual users question like, can you list other uses of a cardboard box, for instance, or asking questions like, write all questions you can think of based on a scene, or circles, or product improvement. So the idea is mostly, if you look at what this test is trying to do, is to separate and kind of discriminate between two types of thinking. One which is called convergent and the other divergent thinking. So in order to summarize this, convergent thinking can be thought as the deductive generation of an optimal solution to one given problem. In math terms, we could say this is some form of projection between a problem space where you have one problem and a solution which should be one solution for each of our problems. But in the case of creativity tests in sociology, we are trying to assess divergent thinking. So the creative generation of multiple solutions to a single problem, and evaluating the answers can lead to one or multiple optimal solutions, which means we have from our problem space several different points in our solution space. So if we would crudely exaggerate what is trying to be done in the social science field for creativity, would be to say that intelligence is a convergent process, while creativity is a divergent process. And this is, I think, the first point where we can try to project the machine learning field on these sociology questions, which is, if we use machine learning to model creativity, would be supervised or unsupervised, you can usually kind of define any problem as being function approximation, right? Where we need to define a function which has some parameters, we evaluate the quality of this approximation, but somehow we are still defining something where one point is leading to one point in the solution space. So the problem is, are we bound to only convergent thinking when we are doing creativity at the era of artificial intelligence? So the good thing is that we still have something very powerful called probabilistic machine learning, where we can say that actually variables follow distributions, and we can sample from this distribution even in multiple dimensions. We can do some conditional process of that. So how do we define this type of probabilistic learning? Is rather than having one solution to one input, we have a whole distribution, which is kind of conditioned by the other. And then, of course, based on the parameters of our model. So why would we try to do that? But because actually, instead of having this single solution, we can model the uncertainty of our process. So modeling the uncertainty is particularly interesting in the case of our generative problems, if we want to do creative machine learning, because if we have the access to this distribution, then we can sample from it. So remember that maybe this problem is too complex to solve, so we usually introduce latent variables. So these latent variables can allow us to simplify the problem, and at the same time, they can provide us with very powerful creative kind of processes, because we can define some simple conditions onto which we're going to generate the corresponding data. So based on that, I tried to thought about the different factors inside the Torrens test of creative thinking. What are the criteria that are used to perform the evaluation? How do we rate the success of people? So the usual condition, and there are hundreds of them, but like the major common ones are the fluency, which is the number of answers which are provided by someone, the originality, which is the unusualness of answers, the flexibility, which is the variance in the concepts, the elaboration, which is precision and details inside the solution, and the abstractedness, which is the levels of abstraction. And then, of course, depending on the paper you read in this creativity field, you have hundreds of different, very specific type of evaluation measures. So we can crudely kind of separate between the innovative aspect of the solutions and the adaptivity, and then you have lots of creative strength of each problem. So of course, the problem now is how our probabilistic learning processes could perform on these criteria. So if we take the innovative aspect, remember that let's say we modeled the distribution quite right, then we could say probabilistic models could have some perfect scores in the number of answers because we can sample quite, let's say, supposedly infinitely. And of course, in the variance, we can kind of constrain how variant we're going to create our examples. But this is kind of a simplistic reasoning because there is two caveats. First is that we kind of define random sampling as a choice on our generative process. And also in the terms of flexibility, even though we can constrain it, it's still sampling from a predefined distribution. So the question of originality is also a big problem because our examples will remain consistent with the dataset we are using. So the system is kind of inherently limited by the model, the dataset, the criterion. And on the second aspect of additivity, precision and details, and of course, levels of abstraction, my point is that I think the problem with machine learning for creativity is first that we are usually using something like that. So we are actually using the expectation over our distribution depending on the data. So this means that first we are bounded by the data itself. And the second is that we kind of basically asking to find a reasonable mean to our problem, which means we kind of tend to look at the major points of distributions and not the single outliers outside. And that's a problem given what we talked about for the IDs and how eccentric IDs are usually where creativity lies, right? And also the problem that this kind of social context where we select the data and model can be limiting to creativity. So the question is, how can we free ourselves from this kind of societal biases, but also how can we evaluate something which cannot really evaluate the unusualness of its own solution? So I think the major approaches in the artificial intelligence for creativity field has been to do something I call mathematical reification of IDs. So we try to reproduce the abstraction and tactics that are playing inside our brains, and these kind of fundamental processes, we try to translate them in computational terms. So it's been a major source of advance, of course, in the AI field. And if we look at how we could reify the processes that has been defined in the sociology of creativity, you can separate between two major categories. On one side, you have the information, which is the source where you take your knowledge, and the operation, retrieval and analysis. And all of these are documented in different papers from neuroscience. You can look at the full paper for this presentation if you want to. So in the information, usually the neuroscience and sociological processes are the organization of the information, the retrieval of this information, and the analysis and transformation, which means we tend to organize information structures so we can simply retrieve some information and analyze the similarity while transforming our sources of information. And while as we have access to this information, then we can perform some modification of the knowledge or associate between IDs or try to perform analogy or abstraction, which is finding general concepts. So I'm going to try to move forward a little bit. So the idea of organizing structures of information, you can find it, of course, a lot in deep representation learning, where we tend to try to create information structures and hierarchy, which is kind of the goal that we've seen from the beginning of deep learning, which is quite interesting because it's also what has been one of the first problems that has been tackled by these neuroscience type of approach. And of course, this pertains to this magnificent idea of the manifold hypothesis, which is that when we observe very complex data, it's usually living on this very low dimensional manifold, which is embedded in this high dimensional data space, which is very relevant to our creative learning problem. So in that sense, we did several studies, notably one where we tried to map the organization of these information structures to time space. So the idea was to try to regularize the latent space of a variational autoencoder so it would follow perceptual ratings of distances. And we did this and we had some very interesting results. For instance, that actually using that, you have a very linear organization of some of the known descriptors, which is quite cool because we didn't do anything for organizing these descriptors, but it's kind of naturally organizing itself around known things. On the information retrieval aspect, so the question is how can we access and retrieve the information? And there is a great model which is called the path of least resistance by Ward, which means that we tend to access basic and specific low-level examples. So I have an example, I'm going to try to play it very fast in this idea, where we try to mimic this process of orchestration by taking piano recordings and trying to have a machine learning model based on attention and neural autoregressive distribution estimation to try to orchestrate the piano score in real time. So the results are quite interesting. I'm going to play a little, be careful. I was told to warn people, this is going to sound. So this is the input piece, and the model is actually producing the orchestration, but it is unbounded, so it could play notes everywhere. And you're going to hear there is some octave doublings. The crescendo is actually mimicked by heading instruments, so there is lots of interesting results here. Okay, moving on because I'm quite out of time. So please tell me when I have like 1 minute left because I'm going to lose myself, I know. So anyways, the analogy inside this idea of operations is trying to project knowledge into a new domain. And analogical reasoning usually connects source and target domains very profoundly. So a loser parallel in what's been going on in the artificial intelligence field is actually the task of domain transfer, where you try to take the properties of one source and you project it on another new domain. But this mostly looks for low-level perceptual properties, and we don't really yet connect profound conceptual aspects. So there has been this great paper recently, which is called differentiable digital signal processing, and we've been working on that as well. So we actually changed it to try to do a granular subtractive model with spectral filtering, which is a similar approach, which is, but still kind of completely different. So we get the same type of transfer where we take voice and violin, but I want to make you listen to more weird stuff that we've been doing at IRCAM. So this is Get Lucky by Daft Punk, but we only transfer the voice automatically. And we use a data set of screech and drills, which means things that are scratched and drill sounds. So it's a weird result, but I love it. Okay, I don't have time, but I have the full track. Another example, which is more recent, a model that we are yet to publish. So this is kind of a spoiler alert. This is called a wave transfer model. So basically, it's a kind of mixture between a variational flow. So this is a new architecture we're going to publish in a few weeks, I hope. but basically the idea here is to try to transfer Céline Dion to growl. So I don't know if you know growl, but in metal and hard metal, death metal, this type of stuff, it's the sound that are produced by doing like, which means growling, right? So this is a real-time model, and we are quite proud of the results because it can work with a pure data external. So you're going to hear Céline Dion singing, and we can transfer in real time. So this is Céline.
I see
and it's going to be transferred gradually, rolling.
That is how I know you.
So the result is funky, but it works for any transfer, but I rather show you weird stuff than classical voice to violin stuff. So I'm going very like the speed of light, but I think there is still some unreachable operations yet for the machine learning applied to creativity problem, like association of existing knowledge, something which is called Januzen thinking. And I think I'm going to try to simplify the problem by saying there is a big problem in how we relate to AI. So the profound limitations depend on the role and place we grant to AI in the creative process. On one side, you have these self-sufficient generators where you just have this huge create button and it creates stuff. So I think this is kind of useless, and we should rather look for creation tools, right? Something which enhance our own creativity. So despite its complexity, it would say that AI remains an evolved brush, like some synthesizer with very advanced possibilities. And in that domain, we recently did something very interesting, which is trying to simplify the problem of audio synthesizers, because you have like audio synthesizer everywhere, and usually approaches that are tried to simplify the use of synthesizer, they did this type of stuff, which means you take an example and you try to infer the parameters of a synthesizer to produce a given signal. What we proposed is instead to try to perform some kind of universal control learning. So the idea here is that AI learns how to simplify the use of a pre-existing object. So we did that by first organizing the auditory space of synthesizer audio possibilities. And at the same time, we organized the parameter space. And then we try to find this invertible mapping between these two spaces. So it can be seen as some form of word model, or you could say that it's an amortization of the synthesizer parameters given the latent space of audio possibilities. And we can still control these dimensions. So the cool thing is that doing this instead of just feed-forward inference means we can automatically infer parameters of the synthesizer from audio, but we also discover some macro parameters of our synthesizer because this space is supposedly well organized. And the other cool stuff we can do is to do audio-based preset exploration, which means we have our presets and we can look around other presets, even though they have completely different parameters, but they sound the same. And finally, we tried to do this semantic dimension discovery. So the model is a little bit hairy on the math side, so I'm not going to talk about this. I'm just going to show you a funky video, which is way better than me talking. So you can find this video on YouTube. So here you can see the model in action in Ableton Live. So this is just me playing notes, show that synths are complex with notes. So we take away files and we just put it inside our model. And you can see that it found some parameters for the synth in less than 50 milliseconds. Works with voices, of course, so you can put your voice. And it will try to mimic, to find the parameters of your synthesizer that do the same sound as what you put. So second aspect is this idea of being able to look at presets, and you can hear that presets that are close together actually sound the same. So you can very quickly explore a solution based on this. So a little advanced. So yeah, where we draw, sorry, I'm simplifying, we draw a path inside this. So this is actually the audio-based latent space. So we select presets based on audio, but it's mapped in an invertible fashion to this parameter space. So you're going to see how parameters evolve in a very non-linear fashion, but it's still very smooth. We'll see the dots moving, but it starts to interpolate in the audio space mapped to the parameters. It should be right now. And the final very cool thing is that we connected this to a leap motion, which means that you can play with 120 parameters just by moving your hand in 3 dimensions. So you can see that all the parameters are moving, so we are kind of finding like huge macro controls, which simplifies the use of synthesizer. Sorry. So I think my time is almost up, or maybe it's completely up. I don't know. Should I stop?
Yeah, I think you might need to wrap up. Maybe if you wanted to sort of summarize a thing or two, that's okay.
Okay, so I'm going to be very fast. So my main argument here is we need to really look at how we define our relationship with AI. So there is this highly context-prone and let's say, societal aspect of creativity, and self-contained generative AI for me is kind of a pointless endeavor. We want to generate novel things, but we're based on existing. So maybe we're going to strongly conform to existing norms by selecting our examples. So creativity traits should be kind of shared between the humans and machines. We avoid to mimic our own preconceptions and redefine this partnership between the human and the machine. So the idea is to emphasize co-creativity. So the interaction control where you have an interplay between the AI and the human creator. So I'd say that somehow we have this inherent limitation where we try to optimize mean accuracy, which is normal, but we must be careful that it does not lead to this infinite norm generating machine, because it would risk overusing these models towards standardization, which would create some form of genetic drift in creativity. So computational approach historically have propelled creativity, and we can find sounds that we could not reach before. But I think this is very important that we also allow to deal with objects that exceeds our perception and try to disassociate ourselves from pure biological mimicry, because one day maybe just AI generating noise will be a great prospect. So thank you. I try to wrap up super fast, and I hope to have many questions.